So in example 8.5, the planet Mars has two moons, Phobos and Deimos. The Phobos has a period. So students, like this is our sun, okay, and we have Mars as a planet, and this Mars has further in its orbit we have two moons, okay, so we have two moons. So I'm enlarging this figure, that this is your Mars now. So students, when I am studying about, so now the formula that I have for the time period of revolution, this T is time period of one revolution, okay, of the orbit. Now what is this formula? T square is equals to, this is equation 8.38, okay, T square is equals to K into RE plus H. So students, whenever you have the formula, you must have the figure in your mind. What is this T, what is this REH? So this was your sun. So here it was Earth satellite, this was your sun, this is here Earth, and then you have this satellite over here. So this was your satellite. So what is this RE plus H? RE plus H, I can also call it R. This distance is R. This distance is R. So that's the orbit's radius. What is this R? Orbit's radius. Okay, so this RE plus H. And if I'm talking about the Earth, which is revolving around the sun, so then this will be the orbit's radius. So we will have two situations here, students. One will be, so this R is between the Earth and sun, right? Earth and sun, and this radius is between the Earth and satellite. Okay, so this is between Earth, sun. Okay, so we will have two situations, so we need to be careful about this. Now what is this K here? The value of K is equals to 4 pi upon GME. That's the value of K. So we have written this exclusively for this formula was for this, okay, for the Earth satellite. So this is the time period of one revolution for the Earth satellite. This is the mass of Earth, this is the radius of the Earth. See, we have nowhere here the mass of the satellite. See, mass of the satellite is not the part of T square. Can you see this, students? So T square is equals to, what is the value of K? 4 pi upon GME into R cube. R cube is the orbit's radius, RE plus H, okay? So that's the formula, okay? So here we have mass of Earth, gravitational constant, and this is orbit's radius. So mass of the satellite is nowhere here. I hope this formula is clear to everyone. Now what do we have in the question? Phobos has a period of, so period of Phobos is given, time period for one revolution, that is 7 hours 39 minutes, okay, and orbital radius is given to you. What is orbital radius? That is 9.4 into 10 to the power 3 kilometer. So this is your Mars now, and this is your so Phobos, which is one of the satellite of the Mars, So the distance between the center of the Mars and center of the Phobos. Okay, this is Phobos, this is Mars. So this distance is your r, orbital's radius. Okay, from the center of Mars to the center of Phobos, and this is the time period of one revolution. So we have to calculate the mass of the Mars. Okay, so same formula here, T square is equals to 4 pi upon G. Instead of Earth I have Mars here, so I will have M instead of G. So this is your equation 8.38. okay, and so now here it was orbit of the Earth, right? Here it is orbit of the Mars. Okay, so orbital radius of the Mars, this r. Now this 4 pi square, this is 4 pi square, students. Here not this value of k you haven't miss asked me to correct it. This is 4 pi square upon gm. So this formula I have written, this for Earth, this is for now Mars. Now I have to find mm. So mm is equals to t square. So this mm will go here. Okay, this mm will go into the numerator, and this t square will come into the denominator. So this is 4 pi square r divided by g t square. Okay, so you need to simply put these values. So students, you need to put the values in SI units. So 7 hours 39 minutes is how many seconds? So 7 hours means 7 into 60, right? These many minutes. That is equals to 420 minutes. 420 minutes plus 39 minutes. So that's equals to 459 minutes, right? And 459 minutes, change it to second. 459 multiply 60, so that's second, right? So this is your time period for one revolution. Now 4 into, what is the value of pi? 3.
Excuse me, sir.
Yes.
Sir, instead of r, there should be r cube.
Very good. Yes, you are absolutely right. So here I have r cube, so definitely it's r cube. And then r cube, so this is your r. So 9.4 into 10 to the power 3. So kilometer is MKS system, SI system, meter, kilogram, seconds. Okay, that's your SI system. So that's in kilometers divided by G. What's the value of G? 6.67 into 10 to the power minus 11. That is gravitational constant into, what is the mass of, what is the time period for one revolution? That is 459 into 60 seconds, right? And you solve it out, so mass will comes out to be 6.48 into 10 to the power 23 kg. Okay, students, done. So we have another part of the same question. Second part. Assume that the Earth and Mars move in circular orbits around the Sun, with the Martian orbit being 1.2. So orbit of Mars is equals to 1.52 times the orbit radius of Earth. Okay, so you know that there is Mercury and then Venus and then Earth and then comes the Mars. So orbital radius of Mars is greater than that of Earth. Okay, so that is given to us. We have to calculate what is the length of the Martian year in days. So what we have to tell? Time period for the Mars. Okay, time period for Mars. Got the question, students? Now what do you have? This same formula, because we have to calculate the time period for Mars. We know the time period for the Earth, for the Earth, one revolution that is equals to 365 days. Fine. So important thing here is that now I'm talking about sun, okay, and these planets around the sun. So now this t square for Mars is equals to 4 pi square r. So yeah, whose radius I'm going to write here, students? This was time period for Earth, so radius of Earth, right? Huh? Or radius of sun? Radius of sun. This is the time period for the satellite, okay? Yes, around the Earth. Yes. So whose radius I was taking? Earth radius. Earth which was at the center, right? So here who is at the center when I am taking the time period of the Mars? Sun is at the center, okay? And G into whose mass I am going to take? Sun mass. Is this clear to you, students? And similarly, now I have for Earth also, and ultimately these are the constant, they will be no more, and I have to connect these four. So this is the only way to get them connected. So what is the formula for the Earth revolving around the sun? Time period of the Earth is equals to, here also, radius of the sun divided by G and mass of sun. Okay. So this 4 pi square same, radius of sun, this R is this R is R for the Mars, yes, this R for the students. One thing is correction over here, that this is the radius of the orbit, okay? So this whose orbit this, so this that distance between sun and Mars, and here the distance between sun and Earth, right? So this will be different, this so definitely this orbital distance will be different, so they are not going to cancel. This is actually what we need to even calculate, okay? So this is radius of orbit sun Mars, or sun Mars, and this is here the orbit sun Earth. But the G is same, and the mass of sun cancels out. So I get t square of Mars divided by t square for the Earth is equals to now this sun Mars, the radius of orbital of the Mars is 1.5 times 2.5 times the radius of the Earth. So let us put this value of this Mars, that is 1.52 into radius this radius, this is radius, orbital's radius of Mars. So this was sun Mars, so now it is sun Earth, right? This sun Mars, so 1.52 times the sun Earth, or you can say Earth sun, divided by this radius is sun Earth or Earth sun, whatever you write, that's your choice. So you can write here, this is your sun Earth, right? So Earth sun you can write. So this is R, Earth, Sun, right? The Martial orbit is 1.52 times the Earth orbit. So that's this value I have put over here. Divided by, this is the only term I left with. So this is the radius of Earth-Sun orbit. Right, this is Earth-Sun orbit. So this will cancel out. And T square Mars is equals to 1.52 into T square Earth. So time period of revolution of Mars is equals to under the root. So what about this 1 point? So it will be students, what's the problem here? This is supposed to be R cube here.
1.52 cube.
Yes, this formula is cube over here. So we have again forgotten this cube, right? So we have cubes over here. So these cubes cancel out, but this cube will remain be there, right? Because this R cube. So 1.52 into R whole cube, and cube will be with both. So this is this cube here, and now this is under 1.52 into, so square root of this, so that's 1 by 2, and so this root, this will remove. And now this is okay, students, square rooting both sides. So this 2 will be removed, so square will be removed. And what is the time period of the revolution? That is 365 days. Okay, so calculating this, the answer comes out to be 364 days. Okay, noted it down, students, note it down simultaneously. Okay, I don't think you will get notes today, so keep on writing it down. Shall we start the next question? Yes. Example 8.6. Weighing the earth. So that's page 195. Weighing the earth. So we have the following data. G is equals to 9.81 meter per second square. We have the radius of earth, that is equals to 6.37 into 10 to the power 6 meters. We have the distance to the moon, so that's our orbital radius. So this radius is of moon, earth, right? Orbital radius of the moon. So orbital radius of moon, right? That is 3.84 into 10 raised to the power 8 meter. You know what's this orbital radius? This is your earth, and this is your orbital radius, and this is your moon. So this distance, center of earth, center of moon, this distance is your RME. Okay, orbital radius of moon. So this 10 raised to the power 8 here. That is given to us, and time period of one revolution for the moon is also given to us, that is 27.3 days. So what we have to find? We have to obtain the mass of earth in two ways. Okay, so first way, so mass of earth we have to find. So first is by the formula which is given by equation 8.12 acceleration due to gravity is given by gme upon re square. So students, these are the two formulas which are important. This g, and second one is your t square is equals to 4 pi square r cube divided by gme. Okay, so moon revolving around earth. Okay, so that's the situation. So this is the radius of the moon's orbit, this mass of earth. Mass of moon, mass of satellite is nowhere. Okay, that gets cancelled out when we are deriving these relations. So now how do we get me from here? So me is equals to g. So me will so g and this re square divided by capital G. Okay, so students, put these values. G is equals to 9.81 and this r is equal to 6.37 times per 6 and this g is equals to 6 point, and you will, when you put these values, you get 5.97 into 10 power 24 kilograms. So this much is the mass of the earth. Now from this formula, mass of earth is equals to t square, this me and t square will be exchanged. Okay, we have written it earlier also. So that's equals to 4 pi square r cube divided by g into t square. Okay, these two, they will be exchanged. Now students, you know these values, this r that is given to you, that is this rme. Okay, so you and then this g, you know, and the value of t, this days, you have to change it into seconds. Okay, so change it into second by multiplying it first with 24 and then with 60 and then with 60, and from here also you will get the mass 6.02 into 10 power 24 kilograms. So almost these two masses are same. So you can find the mass of the earth by these two methods. Okay, shall I put the values here or is it okay? Yes, they are there in the NCERT, and I have told you the values also. Any problem, students?
No, sir.
Okay. Now we have next example, that is 8.7. So 8.7, see, you know that in the formula of t, we have t square is equals to k into the radius of the orbit cube of it, right? Where k is equals to 4 pi square divided by g m e, right? So if I'm talking about the satellite revolving around earth, okay, so students, keep this in mind. That is why revolving around the earth. So earth is at the center and this is my earth at the center and this is satellite over here. So that is why mass of the earth, so one which is at the center, like in earlier question, like sun was at the center when, so we took here the mass of the sun. So this is the body which is at the center, that's mass we are going to take, and this r is the orbital's radius. Okay, now what's the question? The question is that k is given to you. K is equals to 10 to the minus 13 second square meter minus means second square divided by meter cube. Okay, so that's 10 raised to the power minus 13 into second square divided by meter cube. That is given to you. Now you have to express this k in days and kilometers. So change this second to days and this meter to kilometers. So what you will do? So simply 10 raised to the power 13 will remain there. So what is second square equals to? Second square equals to what is 1 second? So assume, students, look, this second square. So what is second, changing it into days? So 1 second, how many days? 24 into 60 into 60, these many days. That is the meaning of and then square. Okay, so 1 second is equals to these many days and then square. Now meter cube. So this is meter raised to the power minus 3. So what is meter cube? 1 upon 1000. Yes, kilometer and raised to the power minus 3. So this is the meaning of 1 meter. So 1 meter is equals to 1 upon 1000 kilometer. 1 second is equal to this. Now this square will go with both. So that's equals to 10 raised to the power minus 13 into 1 upon 24 into 60 into 60 whole square of this, square of 1 also you can write, and then days square. Okay, multiply similarly here. So this 10 raised to the power minus 3. So this 1000 raised to the power minus 3. So this 1000 is so this 1000 will come on the upside, right? 1000 cube into kilometer cube. This is sorry, divided by, so this kilometer minus 3 will, so this will remain kilometer minus 3. Okay, and when you will solve this, you will find that this is equals to 1.33 into 10 to the power minus 14 days square and kilometer minus 3. Okay, students, so that's how we change the units. So this is a method I tell you. Now the moon is at a distance, this much distance from the earth. So orbital's radius is given to you, that is 3.84 into 10 to the power minus 5 kilometer. So this orbital, this earth, this is moon. So this orbital radius is given to you. That is these many kilometers, of course. Now what will be the value of t square? So t square is this. So t square is equals to k into r cube. So this is the value of k, right, and this is the value of r. So simply put this value of k and put this value of r, will get time period. So 1.33 into 10 to the power minus 14. So students, you can see the same thing in NCERT also. 3.84 into 10 to the power 5 whole cube, right? So that's my r. So here I have this is, see why there is minus here, this plus, of course this plus. So 3.84 into 10 to the power 5 kilometer, this is the distance, moon's orbital. So this is plus 5, of course. So when you will solve it, you will get 27. So students, what are the units here? Day square into kilometer cube. So this kilometer minus cube. So this is see what were the units of k? This k, day square into kilometer minus 3. So from here I get kilometer plus 3. So kilometer plus 3, kilometer minus 3 cancels out. Okay, so kilometer raised to power 0 means 1, and I am left with only days square. So and square rooting it, this is because t square, so square rooting it, so this day square will remain, will be converting into days. So see, the units also matched on both the sides. So is this okay? Do it do it yourself. You have your NCERT book along with you. Any problem, tell it to me, because the next concept is very, very important. We will have the exactly same question, exactly same concept in 12th class also. The next question. Okay, all of you have done the example 8.7, understood it? Any queries?
Yes.
Shall we move forward?
Yes, sir.
Okay. So students, next is see, all the concepts are easy. Physics is very easy. It's just the application of mind. So study physics with fresh mind. Okay. So energy of the orbiting satellite. So we have studied the time period, orbital's radius, and now we are studying how much is the energy of orbiting satellite. So energy of orbiting satellite. So of course, you have this is suppose your Earth, and we have a satellite. So that's your satellite revolving around, and so this satellite is suppose at height h. Okay, this is your Earth, this is your suppose satellite, and students, this is your h. This from the center of the satellite to the surface of the Earth, this is your h, and this is the radius of h. Okay, re. So how much is your orbital's radius? So orbital radius is equals to re plus h. Is it okay? Orbital's radius of the satellite, that is your r, is equals to re plus h. Now of course this orbiting satellite has because it is moving, so it has kinetic energy plus potential energy. Okay, so what is the energy of this satellite? The energy of the satellite has kinetic energy plus potential energy, isn't it? So what is the kinetic energy it is carrying? That is half m its speed with which it is moving in the orbit, right? So that speed is v, so half mv square plus how much is the potential energy? What is the potential energy of the two systems? So we know that if we have two systems, this is mass of the Earth and this mass of the satellite. So potential energy is equals to minus g into product of the two masses divided by the distance between them, right? Yes. This is very important formula. We know the formula for the potential energy for the system of two masses. Is it okay? And how much is the force acting between them? Gravitational force acting between them. That is equals to G MEM upon R square. So that is the force acting between them, and it is the potential energy of this system. So how much is the potential energy? It is minus. So this plus minus is minus. So minus G ME into mass of the satellite, mass of the earth, divided by, so what is this R? So R is RE plus H. Means what is the distance between there? So what is R? Distance between their centers. So what is the distance between the centers of the earth and the satellite? RE plus H. That is also the orbital radius, RE plus H. Is it okay, students? Now, what is the value of V square? We know the value of V square by equation 8.35. So V square is equals to G ME upon RE plus H. Okay? So that's the V square. That is equation 8.35. We just derived it. Okay? Equating centripetal force is equals to gravitational force. Okay? And mass cancels out, and we got this equation. So put this value over here. So half m into G. So let me write it GME. Yes, and this m is over here. So this M upon RE plus H. So I put this value of V square over here. Okay. And so then minus G ME M upon RE plus H. Students, very important concept here. Very important. Okay. Understand this thing. You can assume this thing. You can let this thing as X, because that's the same thing, isn't it? So what is X by 2 minus X? What do you get? You get X also you can take common. So 1 by 2 minus 1. So that's equals to minus half, isn't it? It is minus X by 2. So X by 2 minus X is half, minus X by 2. Is this okay? Yes. So what do I get here? Minus 1 by 2x. So minus 1 by 2. And what is your x? This is x. So G M E M upon RE plus H. Student, this is the only way to understand it. Okay. Now look here, what we have just discussed with you. This is your E, right? So this is your E. So what E you have got? What was E is equals to K kinetic energy plus potential energy. Now write all of them in terms of x. This is what your x is. Write all of them in terms of x. So this E is equals to half x. What is kinetic energy? 1 by 2x. What is potential energy? Minus x. Multiply this equation both sides with 2. What do you get? You get minus x. So multiply this equation by 2. What do you get? Minus x is equals to x minus 2x. Have you understood, students, that what is potential energy? Potential energy is twice of kinetic energy with negative sign. What is mechanical energy? That is negative of kinetic energy. See, you can tell the relation between these three. So this is most important thing. So I have written this equation this form, and ultimately this form in terms of x, students. Okay, so what is your kinetic energy? What is your potential energy? So this is your potential energy, right? This is your potential energy, right? So what is this equals to? This is your kinetic energy. So x is equals to kinetic energy. So potential energy is equal to what? Minus 2x. And this is minus 2. What is x? Kinetic energy, right? So potential energy is equals to minus 2 kinetic energy. Okay. And if what is energy, if you want to write in form of potential energy, so energy is equals to this energy minus x, this potential energy minus 2x. So energy is your minus x, and you can write it in both the forms. So energy is minus x, so this is what is x? Kinetic energy. So that is negative of kinetic energy. So total energy is negative of kinetic energy. Okay, and energy in the form of potential energy, if you would like to write, this is x, so I can write it as minus 2x upon 2, and that is equals to potential energy minus 2x divided by 2. So total energy, so students, these are the three relations, 1, 2 and 3. So potential energy is equals to minus 2 into kinetic energy. Energy of the orbiting satellite is equals to negative of the kinetic energy, or energy is equals to potential energy divided by 2. So the important thing is that your net energy is negative. So what does this mean? This negative sign means that this is not free. This is under the influence of the gravitational pull of Earth. It cannot escape from Earth. So this thing we will study in 12th class also, that you have the nucleus, and this is the electron revolving in the nucleus, and the energy of the nucleon the energy of the electron will be negative. So that is why it is and if you give it energy, when its energy will be 0, it will escape from the atom. Okay, so when its energy is 0 or greater than 0, students, so whenever till the potential energy is negative here, it will keep on revolving around the Earth. But if you give more energy to this orbiting satellite by increasing its speed, okay, so it will when this will total will be means what you are doing, because kinetic energy is positive, so you are increasing the kinetic energy by increasing the velocity. So time will come when it will be equal to the this potential. So negative cancels out, and this energy will be 0, and it will be this satellite then escape from the gravitational pull of the Earth. So this is what is written means in your book also, page 196. The total energy of an circulatory orbiting satellite is negative, with the potential energy being negative, but twice the magnitude of the positive kinetic energy. So potential energy is negative, but it is twice that of kinetic energy, right? So I have written all these three relations. When the orbit of the satellite becomes elliptic, both potential and kinetic vary from point to point. The total energy which remains constant is negative as the circular orbit case. This is what we expect, since we have discussed before also, if the total energy is positive or 0, the object escapes to infinity. Satellites are always at finite distance from Earth, and hence their energy can not be positive or 0. Their energy is always negative. Now we have this example. Students, have you understood this concept? Is there anything you would like to ask?
No, sir.
Okay. So now we will do example based on this concept only. So that's example. Students, physics has very easy maths. See what kind of maths you study in your subject. mathematics and see what kind of maths you are studying here. Very, very simple maths, but you don't expect the problem is not with the maths here. The problem is with your mindset. Till 10th class you have studied physics just theoretically, you have studied science just theoretically, and now so you have very simple maths you are doing, very simple. Even 6th class students will understand this thing. So your mind is not prepared. So I'm studying this kind of physics. So you have to now align your mind, and prepare yourself for studying mathematical physics. Okay, because we can express these concepts, physical concepts, in mathematical way. It is more explanatory as compared to I'm writing it theoretically. Okay, so I have a 4 kg satellite. So mass of the satellite is 400 kg. So this is the Earth, and you have this orbit of the satellite. So you have the satellite over here, and this is so this too far I have made, doesn't matter, but this distance, the radius here is 2re. Okay, now how much energy is required to transfer it to the circular orbit? So I want to now transfer it to the circular orbit. Whose radius, what's the radius of this orbit? The radius of this orbit is, so I want the satellite over here. So the radius of this orbit is 4re. So 4re. So I want to shift this satellite from this orbit to this orbit. So what are the changes? Kinetic energy and potential energy. So here we can assume that this is the initial position of the satellite, this is the final position of the satellite. So here the radius is 4re. Okay, so initial radius was ri, was your 2re, and final radius of the orbit is 4re. Students, it's so simple. Okay, so what was the initial? We have just derived the relation. What is this energy equals to energy of an orbit? So this energy is equals to 1/2 into g me into mass of satellite divided by this orbital's radius. Re plus h is your orbital radius, right? Yes, that's the formula for energy of the this is not 1/4, this is 1/2. Yes, students, why you are not telling me this is 1/2? Okay, so this is the formula for the energy of the satellite revolving around in the orbit whose radius is r around the earth. So this is the energy of satellite. Okay, now what was the initial energy? That is equals to minus half g me m upon, what was the orbital's radius? Ri was your 2re. Okay, so 1/2, and this is 1/4. So this you get minus g me m upon 4re. Okay, so this was your initial energy. Now what's your final energy? EF. So EF will be equals to minus 1/2 g me m. The only change is the orbital's radius. So now r is equals to, what is rf? 4re. So put here 4re. So that's equals to minus GME into mass of the satellite divided by 8 times the radius of the earth. Okay, so what is the change in energy? Change in energy is always final minus initial. Okay, so here again students, you can see the same thing. You can assume this value, if this value you are assuming as x, what will be this? Tell me, what will be this? This 8 is actually 2 multiply 4, right? This
minus x by 2.
Yes, very good. So this will be equals to, so if I am writing it as minus x, so this will be minus x by 2. Very good. So what is the total, what is the energy change? The energy change will be final, what is the final value? Minus x by 2 minus what is the initial value? Minus x. So what do you get? Minus x by 2 plus x, and that's equals to x by 2. So of course the energy earlier was it's now the change in energy is means positive, so I have supplied this much of energy. Is it okay? Now put the value of x here. So what's your x? So G, so this is minus x by 2, right? And here I've got plus x by 2, so just minus 2 plus. Is it okay, students? Now put these values, you will get the change in energy. Okay, but here you can simplify more in terms of acceleration due to gravity, so that there will be lesser calculations. So to reduce the calculation, I know that G is equals to, so what's G equals to, students? Yes, tell me the formula, hurry up. Yes, what's G equals to? We did it yesterday. Equation number 8.12. We have done it many
GME by R is
yes, GME by RE, right? Square. So what is we have done it earlier also. GME upon RE. So this RE will go this side. So GME upon RE. What will this becomes? This will becomes G into RE. Yes or no? By this there are two RE na. So one RE will go here. So GME upon RE is GRE. What is the square means? This RE into RE. So what is this equals to? This RE will go here. So GRE, right? Into small m divided by 8. Okay. Now simply if we put the values, G is 9.81 and m is 400, R is 6.37 10 to the power 6 divided by 8. You get here 3.13 into 10 to the power 9 joules. So that is the change in energy. So here which energy is reduced here? You can see clearly that the potential energy is increased, right? Because the distance is increasing, so the potential energy is increased. What we were writing, what's the relation? Let's go back and check. The relation was energy is equals to kinetic energy plus potential energy. So minus x is equals to x minus 2x. So this was x, kinetic energy is x. If kinetic energy is, then potential energy is equals to minus 2x, and net energy will be x. That is minus x, right? Net energy. So students, here we have the this change in energy is the kinetic energy is reduced here, and it So if I'm talking about the change, like change in kinetic energy, change in energy, change in potential energy, all three are changed. So the net change means what? There will be change in kinetic energy and there will be change in potential energy. So can you tell me how much is the, see, this is the change in energy, okay? So this is the change in energy. Can you tell me how much is the change in kinetic energy and how much is the change in potential energy? This is the change in energy. Yes. Change in kinetic energy will be
minus
see
3.1
it is negative
into
of see this negative of minus x is plus x. Okay, so you have here 3.13 into 10 to the power 9, right? So this is what you have, change in energy, that is equal to change in kinetic energy. Change in kinetic is negative of this, so minus 3.13 into 10 to the power 9. Okay, so negative of this is x. Now this is same sign as the sign here, so sign here is positive, so same sign here, but now twice of this 3.13 into 10 to the power 9. Okay, so this is your change in potential energy, this is your change in kinetic energy, and this is your change in net energy. I hope you have understood this discussion, students. So kinetic energy here is actually reduced and potential energy is increased by 2 times. Okay, so its velocity, so now it is moving with lesser velocity, and more is the more it has twice the potential energy, but kinetic energy is reduced by this much. Okay, so the change in potential energy is definitely twice the this change. So now that's the means kinetic energy is reduced, and that's how much it is reduced. And so change in potential energy is twice the change in kinetic energy, and that is this much. So the final is more. So students, one thing, if it is written in your NCERT book, like I don't know, there can be misprinting also, but what is the sign of this sign is negative, okay, in the book, but I think it should be positive, isn't it? This sign should be positive, because then only this is positive, this is negative, then only this will be positive, because this value is my positive. Is it okay, students? So here in the book the sign should be positive, means plus, so change in V is equals to this much. This is your change. So this is Vf minus Vi, and that is equals to plus 6.25 into 10 to the power. So correct this sign in your book, students. Here it definitely potential energy is increased, final is more, so how can it be negative? So that's positive, and you have understood with this reasoning also. So that's all for today.